Director of Engineering at Avista Utilities. David Wade, and I have to check on this because the title's a little bit longer than most. The Executive VP and COO of the electric system at EPB Chattanooga, as well as Emily Wheeler, the VP of Operations at Smarter Grid Solutions. So what we're going to be talking about today is a bit more focused on...
Your mic is muted.
Oh, give me a problem.
I didn't hear a word you said.
Start over.
Good to go.
All right. Everybody can hear me now. Good stuff. And we'll have a voice by the second panel. So we're talking a little bit more about reliability further down the grid. A little bit different focus than we usually hear in conferences. Oftentimes these discussions go quickly into vegetation management, SAIDI and safety targets, focusing on blue sky days, and looking a little bit at what happens during major events. That's starting to change. We have kind of two factors. One, from the macro perspective, we have large storms and the kind of regulatory imperative as well as customer sentiment side that is really driving improvements in how to deal with large storms. On the flip side, we have a lot of equipment going in at the customer site that has drastic implications for power flows. We have distributed solar. There's a continued but not super fast deployment of CHP. We have a lot of demand response equipment, and now the introduction of customer-sided storage. So we have these new resources coming online that affect not just the carrying capacity, not just the power flow, but also the voltage and reactive power on the line, which is both an opportunity and potentially a major problem. So we're going to be getting into that a little bit today and kind of how automating switching technologies, power electronics, distributed energy resources, and how analytics kind of play in kind of an emerging ecosystem of being able to actually troubleshoot down to the feeder level, not just from knowing that one feeder always has problems, but actually being able to survey your grid beyond just the expertise within engineers, but with actual data. So with that, start us off nice and broadly. I'm going to pick on Emily because she's the furthest away, and everyone knows that I get time to run. When we look at reliability and resiliency spending, I know you spend a lot of time in New York City. Where's that going today with utilities?
Yeah, if you don't mind.
Oh, we may have all of them muted. That could be a problem.
Can you hear me? No. Should I scream? Oh, there we go. Okay, so if you don't mind, I'm just going to quickly say what Smarter Grid Solutions does and who we are. So Smarter Grid Solutions is a leading provider of the real-time deterministic control solution we call active network management. Active network management monitors in real time critical grid locations in DER, and when the measurements at those critical grid locations are exceeded, our products take action in real time autonomously to balance electricity flows across those measurement points. This ultimately lets us maximize hosting capacity on the grid, and by the end of this year, we'll have over 250 megawatts under control. Utilizing this technology, our solutions can create up to 3 times more capacity on the grid, and we've proven that we can reduce interconnection costs of DER up to 90%. And I'm going to skip it there. And so back to Ben's question. So being in New York City and having been in New York during Hurricane Sandy, I think what we're seeing the reaction of Con Ed being specifically was just very much on the storm hardening side. So a lot on the physical. So raising flood walls, making technology submersible, building up flood defenses. They even worked with contractors from Denmark to put in flood prevention plans, flood preparation plans. So they've set aside $1 billion for these physical hardening updates. And just more recently, we're starting to see them looking within their R&D team at microgrids. And now with the New York Prize and the awards for those projects coming out, I think more and more we'll see microgrids looked at in that area as well.
And so with that, I know Vista's done a lot of work on reliability lately. It was several R projects that they are finally now pretty much complete, I believe.
Yep.
Mm-hmm. David, you guys have obviously been working hard for well over a decade getting everything set up. The approach you guys have taken to dealing with reliability it's been a lot more automation focused, a lot more technology focused. Can you walk through how that kind of differs from many of the utilities and reactions that they've had, that you've seen in the last few years?
Well, I think we took a pretty much a holistic approach at our entire network, and we started with the idea that we needed a communication system throughout our entire network, and we built a fiber optic system throughout our entire network. We also were able to turn that into a additional revenue center in selling commercial products of video, voice, and data, so that kind of helps support the business case and make it a valuable business case even better. But then we layered on lots of distributed automation. We've put in about 1,200 of automation points on our distribution network, and that's 3,500 circuit miles and about a 1,300 megawatt system. So we effectively have built a truly distributed deployment distribution platform with 1 megawatt sections between automation devices. We inherited a legacy of having lots of small substations and many delivery points. So we inherited in a 1,300 megawatt system 115 substations, which is something that 10 years ago none of us would have thought about designing at all, but today it's turned into what was a disadvantage, a fairly strategic advantage in having a distributed network.
We have somewhat of a similar story, but we leveraged the efficiencies related to having a distribution management system and putting some automation on our system around switch capacitor banks and adding controls to our voltage regulators and putting meters out on our circuitry. And it was really the energy efficiency that we got through conservation voltage reduction or integrated volt-var compensation that built the business case for the reliability aspect. So we had to have these, a communication system to enable the conservation voltage reduction, and we had to have metering across our circuits to enable that as well. And so if we had that, and we also had to have where we put in a distribution management system to run the system. And so we already had those things that were required for the energy efficiency business case. And then we were able to leverage those for the reliability business case, because it's always so hard to put a dollar amount around an avoided outage minute for our customers. So we were able to leverage the communication system and a lot of the metering and the distribution management system, and then put in smart switches on our system as well. And we refer to it as, and we have this in a lot of our system, is economies of scope. So historically utilities take advantage of economies of scale to add value for their customers. And as we get to the grid edge, we're able to take advantage of economies of scope because we have these multiple use cases that we can use for single assets.
And so one thing I do want to ask, with that DMS deployment, it's not across the entire system. Mm-hmm. It was kind of pocketed in areas that would provide most value. As you've gone through and gotten that initial information, has it changed the way you would deploy or how you'd think about deploying technology or moving money towards vegetation management or moving money towards different reliability measures? Kind of how has that process looked for you in adjusting to that?
Well, in terms of bang for our buck for added reliability on our system, the expanding the area of the fault detection, isolation, and restoration with our DMS is definitely the best value for our money, especially in the urban areas where the communication system is less expensive than our rural areas. So we've just incorporated, we have a grid modernization program that we're systematically going through our system feeder by feeder and upgrading it, and that's just part of the standard as we go through, is to add this automation to it as well.
Okay. And that queue, how are you determining that queue right now for which feeders get attention first?
It's actually a pretty complex matrix of a lot of different criteria to determine where we go next. So based on the current reliability statistics, is it low reliability? Is there other work that's being done around capacity needs or other things? And we also regionally try to balance where we're doing the work as well, just based on crews and things like that. So it's pretty complex how we're evaluating that.
So transitioning a little bit, from the vendor side, obviously, Chad, you're around the country a lot. Emily, you're around the country a lot. When you're looking at utilities in response to the last couple of years versus, say, 4 years ago, where it was hardening, plus little piece here or there for some additional automated switching or additional intelligence. Is the conversation changing for you guys? Is the technology adoption and looking towards future technologies changing, or is it pretty much very similar discussions for you?
Yeah, I'll go first. You can certainly pile on being local in New York, but we'll focus on conversations in the Northeast, and I think I can point to a number of different conversations we've had. Excuse me. Sometimes I speak loud. We point to a number of different conversations we've had and things we've seen specifically in the New York market. We can point to the push recently in mid 2014 to deploy non-traditional utilities. That was, again, just approved by state of New York to deploy these technologies. Look at New Jersey, for instance. New Jersey had come out and said that they're going to double the amount of energy storage to overall help with resiliency after a storm surge. The state of Massachusetts, for instance, has come out and pushed the utilities to present a plan. Again, that was in the media to present a plan for hardening the distribution network and talking about a long-term vision. We just saw PSE&G come out with requests for information or solicitation for innovative technologies to help out with microgrids. So by far, yes, I would answer the question that we're having different conversations looking for innovative technologies to overall help with an outage situation caused by a storm. My point, though, really to take home is it enough? If we look at some of the statistics, and I cited the doubling of energy storage in the state of New Jersey, and that's a favorite one of mine. If you look at the spend, it's 3 million doubled to 6 million. And so there's more that can be done, right? When in the same state, there's 400 million being spent on efficiency. Now, those are all great causes, but again, is enough being done on resilience? That's my question.
Yeah, I guess just to build on that in New York, I think what you can point to really is that after Hurricane Sandy, the governor in New York State appointed an energy czar, which is an awesome title to have. And then from that, we've seen the New York Green Bank, we've seen the New York Prize, the community microgrid competition. We've also seen now the REV process and things that will come out of that. And I think really I think that's shown that there's an openness and a willingness to start to take these innovative approaches. And I guess time will tell if it is enough, but I do think that right now the shift is focusing away from just these physical hardening measures to, let's look at these DER solutions that were there during Hurricane Sandy, but nobody could access them. And how do we utilize them in the future, whether it's through microgrids or it's through some other solution? How do we take advantage of that in these vulnerable areas that were without power for weeks?
I think I want to key off that actually. The complexity of dealing with reliability has increased. It seems like, at least, because you're looking at a situation where previously there were 9, 10 categories of focus, which is enough, right? You're talking about standards. I know, David, we talked earlier this year. You mentioned 20 years ago I think EBB put in an order for undergrounding whenever possible. And what are you up to now, percentage-wise?
We started undergrounding every new subdivision in 1994, and we're still 20% underground.
So these things are a lot of long-term measures, a lot of focus. But the conversation has changed to a lot of different things. How does a severe storms? It's not just a safety discussion anymore, and even PBRs, which are when we look at performance-based rates, that's viewed as a very progressive thing, but in reality, the conversations we're having had nothing to necessarily do with that. I wanted to ask you, Tate, because you guys took a very different approach years ago to this, and credit, muni status, you guys have your own regulators. If there's a drive from the city council and from internally, you can do things a lot quicker, but kind of how did your thought process change 5 years ago around reliability?
Well, I don't think it really changed around reliability. I think it's always been a focus of ours. I think we just started to the point of realizing the technology had progressed to a place where deploying something in mass to make these amount of changes. And one of the things that, speaking of the changes, we've seen a 60+ improvement in reliability in the network itself as a whole. But the other thing that's not only driving in a standard is we're able to leverage that as one of the attractions of looking at economic development, because not only does reliability impact our existing customers, the reliability you have on a network impacts the ability to add new business as industry, which is obviously going to be better for that utility in that area too.
And so with that, I'm actually curious, Heather, on your side, is the conversation changing with your regulators right now on what is actually a value, that broadening scope? Like, how is that looking for how discussions are going in Washington?
Right, well, it's definitely different
State.
drivers
Washington
than
State,
Washington
first off.
State, exactly. But definitely different drivers than on the East Coast, because we haven't had, recent extreme event like that. But we actually have, we just received decoupling in Washington. And so, interestingly enough, the commissioners are really driving, they have an interest in driving more standards and service metrics around our customer service, because the concern is with decoupling that that will be one tool we use to gain, make more profit, is to reduce the service to our customers. Since we won't be making more profit based on kilowatt hours with decoupling. And so they're very interested in customer guarantees. So even having some sort of requirement if a customer is out for more than 24 hours that they get a $50 credit on their bill. And they're also interested in more rigorous reporting around SAIDI and safety and things like that. But so that's been an interesting connection for us, that there's been that recent interest that's improved. And it actually, to some degree, can help us value the reliability improvements to our customers when we have things like that in place.
Yeah. Well, that's actually one thing, just quickly. I know we didn't talk too much about this prior, but David, you guys have been one of the big pushers of actually trying to put a number on reliability, an actual dollar sign attached to it. Right. You guys have pushed it hard. How is that looking from a broader perspective in the way of utilities coming online, focusing on something like, I think you guys focus on the Lawrence Berkeley Lab ICE calculator, right?
Right, we did, and we're still looking at how do you take those things and turn it into understanding what's the value to our community, because that, for us as a municipal, it really all boils down to is are we a value to the community, and so we've been working. One of the first things we did, we started working with Oak Ridge National Labs. One of the first things that we've done is go back and look at one of the events that came through our area in 2012, when it would have been one of the, in terms of damage, it was one of the top 10 storms in our recorded history. In terms of customer impact, it wasn't because of the automation, but they were able to go back and look at every customer on that. They dove it down to an extreme level of detail, and we're able to look at the benefit to the community of that one event being a $23 million savings to our community. And, of course, it ended up saving us about $1.5 million in restoration that wasn't included in that $23 million, but the major part is how does it impact our community? So we have been trying to quantify that, working with others, because that's really how you end up justifying your expenditures around reliability.
And those would all be assumed with that effect as actual hard savings. You're not talking about customer sat value or anything like that, correct?
No, that's right.
Yeah. That's very interesting. So I want to transition a little bit away from the broad to, as we said, kind of the distributed energy resources, how that actually affects things on the feeder level. Once again, Emily, I'm going to pick on you to start, especially since you're in New York and I know you deal with a lot of these things daily. One of my favorite discussions within REV because it very rarely comes up outside of, we talk about REV from a setting of a market. There's 28 paragraphs we go through. We have a 30-minute conversation. The last sentence that ends every single panel is, and it's going to improve reliability. Which is a tough thing. Kind of how you guys are working with your platform on things that would actually help in that respect.
Yeah.
Within the conversations you're having, how is that actually going to fit with distributed energy resources either being deployed, targeted, et cetera, from a utility perspective?
Yeah, so I think it's definitely not one of the catchphrases you hear. It's not animating the markets or anything like that. But I do think it is at the heart of what REV is doing, and it's one of the key objectives that no solution put forward can reduce reliability. So I think what you can see is that in the future you could envision the DSP, there's a number of different ways that they could provide this as a service. So if they're going out to neighborhoods, for instance, Red Hook in Brooklyn, which was very badly damaged during Hurricane Sandy and without power for weeks, you'd go into that community and see what the needs are within that location and what services or solutions could mitigate that. So I think reliability as a service, whether it's the DSP that's providing that or they're buying those services and enabling them, that's the kind of markets that REV envisions, that those things are possible. I don't think we'll know what the early REV demos will look like. I think there's a press conference tomorrow. Some projects will be announced, but this is definitely, it's set up in a way where a value could actually start to be put on reliable. So you can imagine if there is an asset within a vulnerable area of the network, could that asset be worth more or provide a higher value product because it's available during this time?
And we'll point out, we're going to be getting into that a lot. I'm going to not pick on you guys as much, but the next panel will be looking a lot at locational understandings of values of assets, as well as difficulties integrating them, et cetera. So you guys got off the hook, actually.
Plug for your next panel.
Yeah. Well, stick around, guys. It's going to be great. It's going to be great. So with that, focusing a little bit towards something a bit more broad, when we look at solar, because that is the thing that pops up far more often than not. Energy storage is usually viewed as a nice thing to have on the grid. It's something that can actually be worked with, and there's not a lot of it yet to the point where it's a bit scary. But when you look in Arizona, California, pockets of Jersey, New Jersey, Chad, I'm actually curious, could you provide a bit on kind of how prepared and how utilities are kind of dealing with that today, and what can be done in the next few years to kind of future-proof things a bit more?
Yeah, sure. Solar comes up in so many conferences, and really, I think answering that question, you need to section out what aspect of solar are we talking about. Are we talking about solar at the macro scale, right? And then I can get on the charts and show the duck belly, and we can all groan and talk through the time of use and the effects on the grid. Or you can take it in the micro scale inside the distribution feeder network. So utilities are taking both actions, right? On the micro side of things, right? There's a couple different problems that utilities are bringing to the attention of manufacturers and designers like GridBridge is first the variability, right? We all know the variability, right? Clouds go over, things of that nature. Energy storage is largely being pointed to as the solution, but there's still problems with integration of energy storage and orchestrating that power. On the fluctuation of voltage that's being seen throughout the feeder network, power electronics are allegedly being tapped on the shoulder to come in and help with that, as well as solve some other problems in the grid. So those are the conversations we're having with utilities about solar on the distribution feeder network.
I know Avista doesn't exactly have a ton, but Heather, I know you deal with a lot of things in the engineering department that may be looking forward a bit.
Right.
Do you have some comments on kind of how you're viewing things and how conversations you're having with other utilities look?
We're really fortunate. Given our current rate structure, we have pretty low rates comparatively. We don't have large differential between on-peak and off-peak pricing historically, but we're seeing more of that, and actually more to the benefit, or more that we could take advantage of in terms of negative pricing. We do see that a lot when we have wind, and then especially seasonally when we have the spring runoffs. We're seeing negative pricing quite a bit, and we're not necessarily able to take advantage of that. And so we're looking at these DER resources more of how can we be opportunistic for our customers as the prices go down and as the functionality matures, because we do have a great network base, and we have a distribution management system, we've got the great metering, so how can we leverage that to provide other value to our customers? And so again, we have, as you mentioned, solar, we have less than 1 megawatt on our system, we have 250 installations, so even though Washington State has some significant incentives, we just haven't seen the customer uptake like they have in other areas. But we are testing a 1 megawatt flow battery, and we're looking at, as far as a lot of things on our system, we design them for the extreme events and for the reliability, but those happen once every 10 years, sometimes. This actually up in Spokane, we're going to see one of those events next week because we've got 7 days of forecasted over 100-degree temperature, and our average is usually 1 day a summer of over 100-degree temperatures. So those are the kinds of times on our system that we will learn a lot about what we can put on our system. But really, those you're designing your system for only a couple hours a year, and so things like the storage battery, it can. One of the drivers can be reliability, but how can we use that resource for all these other purposes? So we have it installed at one of our customer sites, so it can be, an UPS for them when there's specific outages there. It can be for voltage support, for frequency support. It can be used for price arbitrage. So we're really trying to maximize the value of those assets, not just for the extreme events during resiliency, but just for everyday operation. How can we maximize that for our customers?
And I don't think, because we're going to open it up to audience questions in about, once I finish this comment, but it goes into the same thing with a lot of the tools that people are looking at. If you're looking at damage assessment tools for a severe storm that happens once every 10 years, that X million dollars to get that system together, get those processes together, there's got to be some other value streams you get from that. Anywhere from having it be useful for maintenance or having it be a useful thing just to communicate better with linemen. But yeah, that's definitely one of the challenges coming up. So with that, I think we have a couple mics roving around over there. If we have any questions, and I will say you'll be saving them because I only have hard questions from here on out. So David, you're gonna be the first one to get this because you're the second furthest away, and I haven't picked on you yet. You guys, when it comes down to it, you guys have deployed a lot, and we talked earlier this year looking at some next step things. It's pretty amazing to have Oak Ridge actually come on and say we're going to use the live system as a test bed. There's not a lot of distributed energy resources that you have, but I know we talked a little bit about some potential, we'll say, odd arrangements for microgrids, for instance, as well as kind of some next steps in the way of preparing for 5-6 years down the line. For you guys actually getting ready for a more distributed energy system, you might call it, at a high level, avoid acronyms. We're not calling that a DES, anyone. GTM's not calling it a DES. But how are you guys looking at that? What's the preparations or the thoughts that you're coming up with so far?
Well, several things. We're actually in the process of putting in a community solar project. We've started designing a community solar project, which will be our first experience into owning some distributed energy resources. But then we've also feel like by segmenting our system into 1 megawatt bites, it makes it very easy to insert distributed energy resources. We're working with Oak Ridge now in taking the data we have from all of those 1 megawatt systems and understand where's the most valuable place in a number of things, from both a power flow performance to a reliability performance. Because when you start looking at where's the most valuable, there are several different attributes of value you have to review. So we're working with them on taking a deep dive into, out of those 1,200 segments in our system, where's the most valuable places to start putting in a distributed energy resource and what's the value to those places.
Okay. Jed, do you have any?
I mean, I think from an operational standpoint, right, I'll stir the pot a little bit on operational pieces that can and should be in place. And, you know, some of the things that, you know, we can talk about and have been alluded to is, you know, we care a lot about the data, right? All the data's coming back into the substation. We really care and hug and want to get every little bit and byte back to the substation to do some, you know, some processing. So from an operational standpoint, right, I think, you know, some of the conversations we're having at this stage is how do we not build a bigger pipeline? How do we do more decentralized? And this really stems off of, you know, we keep talking about the internet, right? And we keep saying, all right, internet this and the Internet of Things. And, you know, it's fundamental. Decentralized computing versus centralized computing. You know, I was seeing that in the technology scene. Can't date myself too much, but realistically, going from a centralized computer server to decentralized capability offloads a lot of the otherwise processing that would be required back in the substation. So you know, these are really bold operational changes that are required at the utilities to be able to manage a decentralized system with decentralized devices, making decisions and only reporting back what they're doing.
Do we get any questions in the meantime? All right, more tough ones. So actually, I did want to key off for that,
We
actually.
got one back there.
We got one right in the middle.
Thanks. I feel like we got a few good people for this question up here. Throughout the day, and even the pre-conference yesterday, and even tomorrow, everybody's really talking a lot about utilities, and the progressive ones that are making steps in the direction of this kind of future. So my question is this: utilities plus who? Is there any effort or need for expertise to be kind of coincident in terms of like engineering consulting services to kind of deepen the knowledge base when you're planning and trying to go down these types of paths where you're really trying to learn lessons? And I mean, is there space for that, or is it really, or do you really at this stage view it as it has to be like your own internal discovery process?
For us, it's certainly not our own processes. That we work with several different partners. We're using S&C as an engineering consultant on our solar community solar project. We're working with Oak Ridge National Labs and actually have some of their research scientists on site working with us day in and day out, pulling together what's the next steps. We've started a relationship with the research staff at Georgia Tech. So we are reaching out to others to say, okay, we have a lot of opportunities. How do we leverage that now? So I think that for us, it is asking for a lot of help from others.
And very, very similarly for us as well, the battery project we're doing is actually from a Washington State Department of Commerce grant. And so we have multiple partners where we have Washington State University to help us with the control systems, as well as Pacific Northwest National Labs is a partner in that as well. UET, Unit Energy Technology, is the battery that we're using. And then we're evaluating other partners as well. So it's definitely not an individual effort to evaluate these opportunities.
Yeah. And on a project-by-project basis, you can't hold on to every person that you need to implement a larger system. It's not going to be good to hold that many full-time employees. There's only so much that's left for them after that project's done. Mm-hmm. So, some more tough questions. I'm actually curious. So Heather, you guys took like kind of an opposite approach in the way of getting the software systems in place at the high level first, versus David, who got, and correct me if I'm wrong, put most of the systems in place locally, and then built the software on top of that. When you look at something like the decentralized decision making, enabling more than just that one battery, you know, when you're looking 5 years down the line at future technologies, and I know EVs are a pet fun thing for you, so feel free to bring that in as well if you'd like. That decentralized decision making, do you guys start seeing a place, and you could say this is you as a Avista or not? Mm-hmm. Where do you see that place for your utility, for broader industry?
Right. Well, we absolutely see it as a balance and the right solution for the right situation, I guess. And so as we move in, we did things differently as well from most utilities where we didn't put in a broad advanced metering system in our territory. We focused on the distribution side of the meter and getting the benefits that we had specific control of first. And now we're headed down the AMI route in our Washington state territory. And we definitely see opportunity to move some of that decision making to the edge when we put in the AMI system. So, right now we have we have small pockets of AMI, and they have tamper flags and things like that. But right now we really just disregard the tamper flags because so often it's erroneous. And so if you could pair the tamper flag with some voltage changes or other things that the meter has the information to make more intelligent decisions, we would like to see that occur in the industry so that we could depend on. Not just a flag that said I moved, but no, I know that I was tampered with, and you can actually take action based on it.
So initially, rather than focusing on operational changes that mess with the arrangement of the grid or adjust power flows, just simply something that can help with operational processes and not having to send somebody out or ignoring potential information that could be useful. Okay, cool. I'm actually curious on your end, Emily, with initial applications, because you guys are deploying essentially a decentralized solution, a substation-based solution, but
Yeah.
what's kind of the main thrust of applications, at least initially, that kind of get you guys in the door?
Yeah, so typically in what we've seen, I guess, in North America is just congestion, right? So it's where utilities are getting applications for new solar systems, new wind systems, and they're turning down over 50% of the applications that they're getting. So it's where we can then distribute we can put our technology in on, again, like a case-by-case prioritized basis where it's most needed, and then allowing for new generation to come online with the understanding that they could be curtailed, and typically it's about 5% throughout the year. But then they're able to build projects, they're able to build those community projects that they've been looking and interested in doing.
I don't know, I think we have time for probably one more question from the audience, or a fifth of a question if I get to ask my next one. Anyone? No? All right, so here's the fun one, because this will probably lead into likely an entire panel next year. We talk about the potential use of smart inverters, which if you're talking a 30 kilowatt system, 50 kilowatt system, 200 kilowatt system, et cetera, there's some pretty strong value there, and there's actually software systems you can start integrating, right? That's today. But when you're talking about a bunch of small systems, a bunch of residential, maybe some commercial, maybe 1-2 megawatt system on the grid as well, that coordination, actually having some VAR control, how does that look for you guys right now? And I would definitely want either Heather or David, if you guys have some comments on this. How comfortable right now are you guys, and where do you expect, if you're not, how many years is it going to be, and how many proof points is going to be required before we get to that? So I say this could easily be an entire panel. So I'm just trying to absolutely destroy you guys in this one.
So are you asking when we'll want to control smart inverters, or?
So from a reliability perspective, actually getting that in, and obviously we have Rule 21 getting going here. There's the advanced functionalities. When you're talking about shutoffs, it's not an absolutely crazy thing, and it's been done in Europe. It's been done and doable. And usually there's a cutoff for size. But if you're talking VAR control, it's a different beast. It's hard enough to control reactive power on the grid today with 4 devices, much less 400. So getting to that comfort level, obviously it's something that's going to be piloted. It's something that's probably going to be piloted here first. But how many more years, and if you look in the crystal ball, I mean, we talked about REV a little bit earlier, very briefly. One of the things they mentioned is VAR markets and voltage markets. That's after being comfortable with the technology. How many more years are you looking at, do you think, and this is not Avista, but do you think before we even get outside of California, just very specific areas, a comfort level for non-utility owned sources? So I say I pick on you.
I know.
This is a rough one. And it could be a range, obviously, but I'm just kind of curious.
Well, we're very interested. We see it as a tool. I mean, we're excited about getting the smart inverters on our system because we just see it as another DER tool for us to help affect the quality of our system. And in some situations, it might be a very cost-effective, resource for us to use. So, we're trying to test it out with our battery, and we're trying to be ahead of things. Again, we don't have a lot of solar on our system right now, but as that does move forward, we're watching Rule 21 very closely to see how we can, and we're already having that conversation with our regulators about how we can, what's the right way to get smart inverters on our system, to get customers to install them, whether it be requiring it through standards or whether it be incentivizing it somehow. So we just see it as another tool for us to help improve the operation of our system.
Okay. So no dates? Can I get a rough number? And
I think
I'm
it's
not, I
more
really,
based on the
I'm not going to hold you to
penetration
this.
of the DERs.
Yeah.
If they start to increase significantly, then that would probably push up the date. And if they stay on the rate that they're at right now, it's just not a huge impact to our system.
So need-based, something that California will have in the next several years.
Right.
And hopefully everything's tested and good and dealt with, and you get, serial number 5,000 for that system.
But we're actually, I believe we have on our community solar project that we're putting in right now, 450 kW, we're putting in a smart inverter. So we just get some experience from the technology perspective to get comfortable with it.
And David, any comments?
We see the value in smart inverters, and our plans are we'd put smart inverters on our community solar projects that we're doing. We're looking at creating at least initially, how do our interconnection standards that include the smart inverters? I think it's actually sooner versus later. I think it's in the next year or two versus the next 5 to 10 years where we become comfortable. And if we don't start putting those in now and start, whether we're actively using the control schemes and its impact to our network today or not, if we don't put them in as we're connecting up projects, going back and changing them later is not going to happen. So I think it's sooner versus later myself.
Okay. And one comment I actually do want to make. So David actually joined us as well for the council meeting earlier this week. So we talked a lot about DER aggregation and grid services. One of the comments made, so you talk about community solar, it's a large facility, can have a strong impact, right? Was maybe for grid services, not everything needs to be connected, because there's a peak in how much you actually need in the way of reactive power compensation. There's a peak in how much you need for frequency regulation. So maybe at least for some time, that those larger facilities are all you need for a few years, depending on your territory. HECO's a special case. So with that, I'm actually going to stay up here. I just wanted to, everyone, thank all our panelists for joining us today.